Okay, so let's go over the homework, and then we'll go over a few more examples just to make sure you guys are comfortable with all of this. Let me just check one thing real quick. Okay, all right. So for homework, you're given a situation. You're at a mountain resort, and you're taking a ski lift to the top of the mountain. The cables from the bottom of the lift to the top measure 890 feet. If the angle of elevation the cables makes with the ground is 35 degrees, how far up vertically does the ski lift go? All right, so you had two parts for this question. Same situation for both, so I'm just going to draw one picture. All right, so we got our ski lift. Really crappy ski lift. Hopefully not too many people go on it. You might get hurt. All right, so be careful with the information they tell you. Okay, this is why I always tell you to draw out the picture. All right, so right now, obviously we need to set up a triangle. All right, so we're going to use the ski lift ropes, the cables, and then we have kind of the bottom of the mountain, and then going up to the top of the mountain. Right, and then obviously there would be our right angle. So if the picture kind of confuses you because there's a lot going on, then just redraw it without everything happening. All right, just draw a smaller triangle off to the side. So they tell us two things. They tell us that the cables measure 890 feet. So be careful where you put that. All right, here they're telling us the hypotenuse is 890. Okay. Then they tell us that the angle of elevation is 35 degrees, right? So looking up like that, we have 35 degrees. So I can put 35 degrees here. So the first thing they ask is how far up vertically does the ski lift go, right? So the first variable that we can place, I'm going to call this over here y, because this is my vertical part, right? Another keyword there is up, right? How far up does the ski lift go? They might not say vertically. I put vertically in there to kind of help you, to give you a little hint. But come time for the finals or whatever it may be, you may not see that, okay? So before we do anything, we have to determine which trig function we're going to use, sine, cosine, or tangent. Well, like we said, okay, the 890 they gave us was the hypotenuse. Now, if I'm looking for the vertical aspect of my triangle, in this case, with the 35 degrees being over here, I'm going to be looking for the opposite side. Right? So I'm dealing with the hypotenuse and the opposite. So that tells me I am focused on sine. Right? There's our function. So we're going to plug in what we know, and we're going to solve for what we're looking for. So I'm going to have the sine of 35 equals y over 890. Right, so yesterday we saw this, and we can multiply both sides by 890. I don't want to forget the degree sign. All right, so we can calculate our y by doing 890 times the sine of 35. All right, so we can type in 890 sine of 35. Make sure I am in degree mode. I am. So the mountain is 510 feet high. Or did I tell you? Yeah, feet. We'll say 510.5. Okay, we'll round that to a 0.5. All right, so your first answer is 510 feet. So that ski lift brings you up a height of 510 feet, even though you're traveling technically 890 feet diagonally. Okay, any questions about the first part? All right, so for the second part, we had the same scenario, but I asked you to find the horizontal distance that it covers. All right, so how far from the starting point, if I measured horizontally to the end point, how far would it cover? Right? So we already know that this is the hypotenuse, that's the opposite. So the other side that I would be looking for would have to be the adjacent. For the adjacent, now here, okay, we have a few things that we can do. Actually, I could use Pythagorean theorem because I have two of the sides, and I'm looking for the third. So that's one method. If I stick to trigonometry, which I'm going to do, I have two options. I have the adjacent and the hypotenuse, or the adjacent and the opposite. My suggestion is always use what was given to you, just in case we made a mistake and this isn't really 510. All right, so say something happened and maybe I did radians instead of degrees, or maybe I chose the wrong function, right? And I didn't get 510 here. If I use that 510 to help me find the horizontal, because this is wrong, then this is going to be wrong. All right, so my recommendation is to use the original number given to you. All right, so I'm going to stick with the hypotenuse, 890. And now I'm looking for the adjacent side. All right, so that tells me I'm looking for cosine. All right, so our setup is actually going to be very similar to this one, except I'm using cosine instead of sine. All right, so I get the horizontal distance is 890 times the cosine of 35 degrees. And the horizontal distance is 729 feet. All right. And real quick, I'm going to do a quick Pythagorean theorem. I'm going to use the larger calculator so I can set it up. So if I have my two sides and I square them, and then I take the square root, it should give me my 890, right? So I'm going to do the square root of 510.5 squared plus 729 squared. And that's really close to 890 because we rounded these two. Okay, it's not going to be accurate, but 889.9 is as close to 890 as we're going to get without being, exactly precise. All right, any questions about the homework?
No.
All right. Let's see, what do I want to do?
Mr. Murray,
What's up?
if we left one of the numbers, like 729 with decimals, like 0.04, would you mark it wrong or?
No. I'll never mark you wrong for giving me more information. I just rounded because we were just doing it quickly. But
All right, thank you.
here we are. That's no problem. All right, let's see. Which one do I want to do? Okay, I like this one because this is an actual thing people do and not just some silly scenario like trying to measure a tree. All right. So one situation where trigonometry is heavily used, like I said yesterday, is when we do when people do surveying land. All right. So something that's difficult is measuring the width of a river. Right. You have to worry about the current. Um, if you don't have a boat, you're just standing on land, but you need to know how far across the river you need to go. If maybe you're building a bridge, maybe you're just trying to get across the river. Maybe you're doing some environmental work, what have you. But you have no way of actually getting across the river, but you still need to measure how wide it is. All right. So we want to find out how wide a river is. So what they do is they start at some point here. We'll call it point A. Right, and then they measure some distance going downstream or upstream. Right, so they walk along the side of the river, and then they use that tool that I tell you about. Right, so they mark some point on the other side virtually, and then they look, right, and they measure this angle that's over here. Right, so they use that tool. Right, so he walks downstream a little bit, and he looks back at the original point that is straight across, and he measures that it's in this case it's 52 degrees. All right, so we're going to use only those two things. Oh, this isn't 70 degrees. That's just 70 feet. We're going to use those two numbers to find the distance across the river. All right, so actually, now that we got it set up, it's pretty straightforward. All right, we want to...
Wait, I have a question before we begin. So, when it's a problem like this, it's usually going to be an angle of elevation since it doesn't see it.
Right. Technically, we're not looking up or down, so you won't see angle of elevation. You'll just see them say, the angle it makes with whatever is, 52 degrees.
Okay, thank you.
Right. So yeah. So in this particular case, we're not dealing with angle of elevation. Correct. All right. So here, okay. I wanted to do another problem. We'll finish this one. This won't take too long. All right. So we want to find the width of the river. So with this 52 degrees, this side here is going to be my adjacent side. The width of the river is going to be my opposite side. Okay. Notice we don't really care about this. We just put it there so we can set up our triangle. Okay. There wouldn't be any reason to really find this, right? I'm just looking for how wide the river is, and to do that, you measure a straight line across, right? Finding this diagonal line wouldn't really benefit us at all. So we're dealing with the opposite and the adjacent. So that tells us we're dealing with tangent. So I'm going to have the tangent of 52 is the opposite, which we have as W, over 70, which is our adjacent. Right, so we can find 70 times the tangent of 52. And here we get that the river That's right. Is so here I'd say maybe like 89.6. All right, 89.6 feet. All right, and if I'm just trying to measure, then I could maybe round it up to 90. But if I'm building something across the river, again, I want to be as accurate as possible. Overestimating would be okay, but if I said 89.5 and I try to build a bridge, I might end up, a little short. So again, yeah, to answer your question again, the more accurate you are, the better. All right, one more example. Okay, so going back to an angle of depression now. All right, I wanted to show you one of these. So here we have a skateboard ramp. The skateboard ramp covers a horizontal distance of 13 feet. It has an angle of depression from the top of 18 degrees. How long is the ramp? All right, so the way this one is worded, be careful where you put your numbers. All right, obviously at first we're going to draw a picture, right? So here you have the ramp, and it comes up like that. Okay. It covers a horizontal distance of 13 feet, right? So that means if you just measured along the ground from where it began to where it started, that would be 13 feet. Now they tell you that it has an angle of depression of 18 degrees. Be very careful here. The way we set up angles of depression, okay, I have to have some top part and it goes down, okay? If it's not that way, it'll look like that, okay? A big mistake I see is they see this 18 degrees of depression and they just put 18 here. Okay, that's not where it belongs. When you have an angle of depression with a situation like this, what you have to do is kind of imagine or draw an imaginary horizontal line up top. This angle up here is our angle of depression at 18 degrees. Now you may be saying, oh, Mr. Murray, that's outside our triangle. That's not going to help us. When we draw this invisible line, we go back to doing something in geometry. This invisible line and the bottom are parallel. And this is cutting across. If this angle up here is 18 degrees, we can use our angle rules. This is an alternate interior angle, so this is also going to be 18 degrees. All right, so just be careful with that. All right, if you put the 18 degrees here, you're going to get completely different answers. All right, so I can kind of get rid of this part now because now I have everything inside my triangle. All right, but I'm going to keep it there just so we have reference to the original 18 degrees of depression. Now they are asking us, how long is the ramp? Right, so I want to know the actual length of the ramp here. All right, so we have an angle, we have a side, and we're looking for another side. We have everything we need to set up our trig problem. So with this 18, my 13 feet is my adjacent side. My x is my hypotenuse. That's what I'm looking for. So I'm going to deal with cosine. So I have cosine of my angle. Now this I wanted to show you because now the value that we're missing is in the denominator. So I'm going to show you how we deal with this, and then I'm going to teach you a little trick. So technically how we deal with this, there's two ways. I could take the reciprocal, or I can do it in two steps. I can multiply both sides by x. And then I would have to divide by cosine. The trick that I like to tell everybody to use is anytime you see a variable in the denominator, swap those two values. All right, so you're taking the x out and you're putting whatever's over here in its place. Okay, so that's just a quick shortcut in case you get kind of stuck. All right, now here, just be careful when you're plugging it in. Obviously, again, with a calculator, you can type it as it is, 13 divided by the cosine of 18. And so we get 13.7 feet. All right, going across there. All right, so not much longer than this, which means that this is probably going to be pretty small, but they didn't ask us for that, so I don't care. If you have your phone, if you're using your iPhone, this is a little tricky. You have to calculate the cosine first. So there you're going to have to round. So you would calculate the cosine, and then you would do 13 divided by whatever answer you had. So I would do, well, in your case, you would hit the 18 first, and then cosine. So you take the cosine of 18. Right? So here we get a really long decimal. I'm going to say 0.951. Right? So then I'm going to do the 13 divided by 0.951. Where's that? 0.951. And it's a little off. Oops, what'd I do? Okay, it's a little off by 0.10. I keep doing that, son of a gun. But you get the idea. It's not going to be perfectly accurate because you're not typing everything at once. All right, but it'll be close enough. If you give me an answer that's, if you told me 13.6, I wouldn't mark you wrong. I usually give you some room for error there. All right, any questions? All right, so keep an eye out. You're going to have another problem tonight. And then we're going to take a little break from triangles, and we're going to learn something brand new. And yeah, all right. Have a nice day. I'll see everybody tomorrow.
Bye.